We are on 5-10 factoring using the GCF. The objective here is to factor a polynomial using the GCF of its terms, okay? Now at first it's going to seem like it's really complicated. There's so many steps, but really there's really 4 to 5 main steps that you're going to want to take here, okay? I've kind of given you an example of all the steps here kind of combined. This is kind of like an end product. So we started off with 12t to the 6th minus 6t cubed. We factored them out. We found the GCF. We divided this polynomial by the GCF. And then this was our end product right down here in the dark blue box. Okay? So I'm going to take you through all these steps on how to get to that final product. Alright, so factoring using the GCF, the first thing we're going to do here is write out all of the prime factors of first the coefficients, then writing out all of the exponents of the variables. So, our first polynomial here is 6x squared y plus 45x cubed y squared. Okay, if you see down here, I've simply just written them out in their prime factors. So, prime factors of 6 are 2 times 3. I have x squared, so that's why I have x times x, and I have 1y, so there's 1y there. Now, again, if you are somebody that still needs to do the factor trees for the numbers, you're more than welcome to do that as well. I could just do this in my head, so that's how I got for 45, 3 times 5. Then I have 3 x's and 2 y's. Okay? That's the first step. Alrighty? Second step is to find the greatest common factor of the numbers or the coefficients. Then, what is the greatest number of x's and y's that these guys have in common? Okay? So the biggest number that 6 and 45 have in common is going to be 3. Just circle that right there for you, okay? So these guys are in common. Then how many x's do we have in common? Okay, now granted, we have 3 on the second one and 2 in the first one. So how many do we have in common? Well, we have 2 up top, 2 at the bottom. So I'm going to circle those as such. How many y's do we have in common? We just have 1 y in common. I'll do that in red. Okay? So then we're going to write it out in the GCF. Okay? Sorry about that. So the GCF is going to be 3. We have 2 x's, so that's going to be x squared and 1 y. Okay? That is our GCF. That's how you find the GCF. Okay? That's the first step. Alrighty, now on to the third step. Okay, we're going to divide the polynomial by that GCF. Okay? So we go back to the original polynomial. Divide each term. So 6 divided by 3. Down below is going to give us 2. Okay? Now, again, we go back to what we just did in the previous lesson with dividing exponents of variables. We're simply subtracting them. We have 2 x's here, 2 x's there, 2 minus 2 is 0. Those are going to cancel out. 1 y on top, 1 y on bottom. That's going to cancel out as well, actually. Okay? Alrighty. So that's our first one. So then we have over here 45 divided by 3 is going to be 15. Cancel those out. We have x to the third over x to the second. It's going to give us x to the first. Then we have y to the second over y to the first. That's going to give us y right there. Okay? Alright, so now we've just divided the polynomial by the GCF. Okay? The last step here, oops, sorry about that. Sorry, oops. The final step is to then apply it as using the distributive property. So, this is what we do. We take our GCF, which is right here. Write that down. Okay, then we put our product, or our quotient from the division problem we just did, in parentheses. 2 plus 15x to the first. Okay? I'm sorry, 2 plus 15xy. Gosh. Alrighty, so this is our end-all product. Okay? If you distributed this monomial to each term in the parentheses, you would end up with 6x squared y plus 45x cubed y squared. Okay? That is, and that's really all you do. I know it seems like it's a lot of stuff at first, I totally get that. But once you get in the swing of things, it's really not that bad. Okay? Alrighty, the next thing here, a polynomial whose terms do not have a common factor other than 1 is called a prime polynomial. So, right here we have 9x squared plus 16. Okay? Now, I'm just going to spell these out for you just so you can kind of see with your own eyes. 16 is 2 times 2 times 2 times 2. Okay? Now, do they have any numbers or any exponents in common? No, they do not. So these right here would be a prime polynomial. Okay? So just keep that in mind. There are times when you'll see that on your homework or on a quiz or on a test. And if you can't find any common numbers or any greatest common factors, it's just going to be a prime polynomial. Simple as that. Okay? Alrighty. So just keep that in mind. Alrighty, so right up here we have 14x to the 5th plus 42x cubed. Okay? So again, I kind of did a lot of this for you, so if you want to pause the video and write it down all the way up to the GCF of 7x cubed, you're more than happy to. So go ahead and pause the video for us. Okay, welcome back. So you obviously found the GCF of 7x cubed. Okay, I'm going to then divide my polynomial by 7x cubed. 14 divided by 7 is going to give me a 2. Takes care of that. X to the 5th over x to the 3rd is going to give me a positive x to the 2nd. Oops, sorry about that. Plus 14 divided by 7 is going to give me 6. Alrighty. X cubed over x cubed is going to cancel out, so this is our final quotient. Okay, now, I want you to look at that right here. Can this bad boy be factored? Is there something that's still in 2x squared plus 6 that can be factored out, or is it totally simplified? You are correct. You can divide 2x squared plus 6 by 2. So, this is how we do this. So before we do that, let's write our product here. So let's do our GCF on the outside, then our product on the inside, plus 6. Okay? Again, I can still divide each term by 2. Okay? So this is what we're going to do. We're going to divide each term by 2, like that. Okay? So that is going to give us, I'm sorry for the messiness of the sheet here. So, because we divided each term by 2, we're going to then multiply our GCF by 2. So that's going to give us 14x cubed, in parentheses, x squared plus 3. Okay, remember, you want the products inside the parentheses to be totally simplified so they don't share any other common numbers or factors. Okay, so that is where you would that's kind of like a two-step factoring, but you'll see that just a few times. Okay, so right now I want you to pause the video, and all I want you to do is to find the GCF of this polynomial. So just find the GCF and then stop there and hit play when you're ready. Okay, so the GCF of this polynomial would be 4x cubed y squared, so I simply just set it up as going straight into the division part. So let's get this party started. So right here in the first monomial, that's going to be 2x to the 2nd, and the y's cancel out. Minus 16 divided by 4 is going to give us 4. It's going to give us at 1x and then 1y. And then 12 divided by 4 is going to give us a positive 3. The x's cancel out, which just gives us a y. And remember, our GCF is going to go on the outside of the parentheses to be able to distribute it. So our final product is this. You know, it's not going to give me enough room. Yeah, well, let's see. If I didn't write so big, we'll just scribble it like that. Okay. So this is our final product. 4x cubed y squared. In parentheses, we're going to have 2x squared minus 4xy plus 3, plus 3y. That, my friends, is your final product. Okay, remember, after you find your GCF, divide each term in the polynomial by the GCF. That'll give you this bad boy. Slap that in a parentheses, slap your GCF on the outside. So that if you and this is really easy to even check your work as well. If you want to go that step further and check your work, all you would do is distribute like you would in any other problem, and you need to get this as your main answer. Okay? Alright, so right now I want you to pause the video, do each of these problems, numbers 1 and 2, and you're ready, hit play, and we'll check your answers. Alright. Alrighty, so number 1 is a prime polynomial. You'd have seen that if you, if you looked at 21 and 10, there's no numbers that go into both 21 and 10, and then the t cubed and x are two very different variables, so they have nothing in common, so that's why it's a prime polynomial. Number 2, the answer was 6x, in parentheses 4x squared, plus 3x plus 2. Okay? This next one, I want you to pause the video and complete it to your best degree, then hit play when you're ready to see the answer. Okay, so my final answer here was 16c cubed d to the 5th, in parentheses 2c squared, plus 3d to the 4th, minus 1. Okay? Alright. Good luck. If you need to see this video more than once, it would not be a bad idea. I understand it is a new process. It's a lot of stuff going on, but it is as complicated as you want to make it. Okay? So try to keep it as simple as you can. Okay. Bye. Good luck.